So good afternoon my dear students. So I welcome you to NEET World, and today is our 5th day. So we are continuing our bridge course. Okay, so in this session we will be discussing about periodic properties. Okay, and after doing that we will do some questions, then after we will start chemical bonding. Okay, so in the last class what we discussed, once just give me a quick revise. Classification of elements. Yes, tell me what we discussed there. Properties, basic idea about periodic table and electronic configuration, right? So now let us start this. Yeah, so this is a periodic table we have seen. So we have seen about S block, P block, D block and F block. So F block elements lies in which group I told you? Third group, and lanthanides are in 6th period, actinides are in the 7th period. Okay, then next here we have metals. As we go from here to here, here non-metals, and here we have this yellow line which are metalloids. Okay, then next what we discussed after this, valency and the like properties like atomic size. Then next metallic. Yes, tell me what about metallic and non-metallic properties. Down the group what happens? Metallic nature. See, metallic nature means those elements which show electropositive nature, right? So down the group electropositivity increases in the periodic table. So metallic nature down the group, metallic nature down the group increases, right? From left to right decreases, metallic nature decreases from left to right, right? And then next what we discussed after that, see, across the period decreases, across the period down the group increases. Next, non-metallic character inversely proportional to atomic radius. It means as atomic radius increases, metallic character also increases, non-metallic character decreases. So down the group atomic radius what happens? Increases, as well as metallic radius also getting increased. Okay, that is what we discussed. The next, what about electronegativity? I told you if A and B are the two elements, in between them we have a covalent bond. Okay, so it is a measure of tendency to attract the bonded pair electrons towards itself. These are the bonded pair electrons. Now if element A is attracting the bonded pair electrons towards itself, it means electronegativity of A is more than the B. Like that we can understand. Next, what about ionization energy? Energy required to remove outermost electron from an isolated gaseous atom. It means, for example, A is an element which is in gaseous state, okay, and it is an isolated atom. Okay, now the amount of energy, see now element A have some electrons now, out of that amount of energy required to remove one electron from its outermost shell. It means if we remove one electron it will become unipositive now, yes, and one electron will be released out. Okay, so this process is what? Ionization energy. It means from here in this we have like orbits we have, from outermost orbit we are picking out one electron. It means do we need to supply energy or it will release energy? We need to supply energy. So this is ionization energy is endothermic process. What is that? Endothermic process. I can also say delta H is positive for this process. Clear now? Okay. So now if we want to remove one first electron, that is first ionization energy. Second electron, it means from here if we remove one more electron, that will be second ionization energy, like that. So if we compare IE1 and IE2, so which energy is more? IE1 or IE2? IE2 is greater than IE1. So always successive ionization energy increases, you can remember, because as electron is removed, the nuclear force of attractions on the electrons by the nucleus increases, therefore it requires more energy to remove the further electrons, right? Then next, Izan, hello sir, how are you sir? Izan, good afternoon Izan. So you can listen to the class. If you have any queries you can write in the comment box. Then next, this is about electronegativity we discussed now. So now we have this is the electronegativity values in the periodic table, you can remember. Okay, so one which is having highest one is what? Fluorine. Okay, so now we have Pauling scale and Mulliken scale to give this electronegativity values. Okay, so now fluorine is the highest electronegative, after that oxygen, then after that nitrogen and chlorine is almost having near values, okay, 3 3, okay. So like that, so as we move from left to right this side, what happens? Electronegativity increases. So electronegativity increases, and here we have non-metals now. So non-metals are electronegative. Here we have metals. So metals are electropositive. So when a electropositive metal, for example, we have a electropositive metal. So let us say sodium we have, and electronegative metal, let us say chlorine we have. So when a metal and a non-metal are combining, they will result to form ionic compound, okay. So about this we will discuss later, okay. Now again, a metal and non-metal combining to form a ionic compound. Between two non-metals, let us say between two non-metals, covalent, because chlorine required 1 electron, this chlorine also required 1 electron. Formation is bond formed by sharing of electrons, which we are calling it as covalent bond. So we will also study about chemical bonding today itself, okay. Next, so those who are in live, so you can take a screenshot of this, so that will be useful for reference, okay. Arrange the following in the increasing order of electronegativity. Tell me, this is the last year's question. Sir, I am the only one watching. Afzal, good afternoon. So there are two students in the chat box. So just ask me if you have any queries. Okay, yes, tell me. So we know fluorine is highest. So fluorine. These are the two options we have. After that, oxygen is there in this option only. So go with second option. Easy question, na? Yes. Now what about radius, ionic and atomic radius? So always remember, when I am taking an atom, A is an atom, A minus is the anion of this atom A, plus is the cation of this atom A. Now tell me what is their order of atomic radii, size order. So we already discussed, negative charge will be having, see, negative charge means more electrons now, it means electron cloud is spreading too much extent, therefore its size is bigger than this, okay. Then always remember anion, atom, least is cation, okay. Now I am writing A plus 2, yes, tell me now which is more size? A minus only, least is, I am writing A plus 3, I am writing A minus 3, large. Is this clear na? Now tell me, here positive charge is increasing, so how the order should be? More positive charge, smaller the size, so it should be like this, but they given in the reverse order, so wrong it is. See, these are isotopes now, there is no effect of isotope. Isotope means just number of neutrons are different, right? There is no effect of neutrons here, so they should be have almost equal size. So but they given in the different order, that is also incorrect. What about this? Cation, potassium plus means 18 electrons, Cl minus means also 18 electrons. Same electrons but negative charge is there here, which is like this it should be. So this is also incorrect. Okay, now what about this? P plus 3, P plus 5. Larger size. So this is correct only now. Which option is correct? That's it. Clear now? Next. What is electron gain enthalpy? Tell me, what is electron gain enthalpy? See, for example, atom A is there. Again, let us consider. See, when an electron is added to neutral gaseous isolated atom X, so they are saying X now. Let us take X only, as per the definition we have written. To convert it into negative ion. So this X is converting to X minus. The enthalpy change accompanying during the process is defined as electron gain enthalpy, delta EGH. Okay. The electron gain enthalpy provides measure of the ease with which an atom adds an electron. It means this delta H Eg, if it is more negative, it is more easy to add the electron to this. If it is more positive, more difficult to add the electron. That's it. More negative, easier to add the electron. Means more amount of energy is released. If a system is releasing energy, its energy decreases, it means it is gaining more amount of stability. Low energy, more stability. Okay, so X is should be what? A neutral gaseous isolated atom converting into this one. So by adding electron, what we are doing? So we are adding this electron to this. So generally more negative, more easy to gain that electron by that element. Okay, that is what electron gain enthalpy we can say. Okay, now tell me for this question, answer that. As we move down the group, metallic character increases, atomic radius increases, but they are saying decreases, so incorrect. This one, non-metallic character decreases, they are saying increases. Nuclear charge increases, atomic number increasing, nuclear charge also should increase. Next, what about this? Element with maximum metallic character, which one? So down the group metallic character increases, all elements belongs to same group, so this one will be having maximum. Next, total number of vertical columns now long form of periodic table, 80. What we can call them? Groups. And 7 horizontal rows. Next, what about these? Oxides are there. Okay, so now if electronegativity difference is more, it is more than 2.3, then we should say them as, for example, here oxygen is there, oxides means oxygen should be there. So oxygen is more electronegative element, combining with some electropositive elements like sodium, lithium, potassium, like this. So they will results to form, due to low electronegativity, due to high electronegativity, the difference between the two elements, the electronegativity difference is, that will be more than 2.3, so that it will be considered to be basic oxide. Why basic oxide? What is the oxide formed by combination of these two? Sodium and oxygen? Sodium oxide. So upon hydrolysis, if an oxide is there, if that oxide is upon hydrolysis, if it is forming basic hydroxide, if it is giving giving hydroxide which is basic in nature. See, NaOH is basic na, basic compound na. If we are after hydrolysis, if we are getting basic compound, we can like base if we are getting, then this oxide is considered to be, is that clear? If an oxide is there, upon hydrolysis, acid is evolving or releasing or producing, what we can say this oxide as? Is that clear? Yeah. So now electronegativity difference is very less than 2.3, then we can say them as so non-metallic oxides are acidic oxides. Okay, so for example, we have something like this, carbon dioxide, upon hydrolysis produces carbonic acid. Carbonic acid I am saying, this is acidic now, so oxide is called now, clear? So few elements like aluminium oxide is there. Okay, so that will be amphoteric, it will be having 2.3, so it will be amphoteric in nature. Okay, so amphoteric means it can react with both acids and bases. Okay, so now here I have listed few oxides which are acidic oxides, basic oxide and amphoteric oxide, neutral oxide also. Okay, so neutral means they won't react with acids as well as base, but amphoteric can react with both. Okay, now acidic means I explained this like this, non-metal oxides are acidic oxides generally. Okay, and metal oxides in their higher oxidation states also acidic oxides. Okay, then next, so these are the acidic nature order, you can remember. Okay, so now how I am giving this order? See, nitric acid, carbonic acid, boric acid I am giving. So just find the oxidation state here, +3 for boron, +4 for carbon, +5 for nitrogen. See, nitrogen is electronegative element which is more electronegative than carbon and boron, and nitrogen is having higher oxidation state, highest number. All of them are in their maximum oxidation state, but which is having maximum? Highest number is which one? So nitric acid is more acidic than the remaining two. Now I will be adding one more thing which is very very important, okay. Now I am adding sulfuric acid also here. Now tell me, here it is plus 4, here it is plus 5, this is plus 6 for sulfur. Now tell me which is more acidic out of this? Plus 6 is higher now, so that will be more acidic. You can remember like that. Is that clear? Yeah, like this. Okay, this list is very very important, list of oxides. Okay, because in the exam they will be giving you a few options. Identify basic acidic from this, like that. Isoelectronic species means? So tell me, what do we mean by isoelectronic species? Same number of electrons. Species with same number of electrons. Give some example. Species with same number of electrons. Give some examples. Sodium plus I am writing. How many electrons are there? 10. Next, F minus I am writing. How many are there? O minus 2 I am writing. How many are there? Mg plus 2 I am writing. 10. Al plus 3. N minus 3. So these are what, no? So for isoelectronic species, what I told you, cation, atom, anion. Which is larger size? More the negative, more is the size. So which is large in size here? N minus the nitride ion, like N minus 3 is larger than O minus 2, then F minus, like that. You can order, you can arrange now, like that. Next, match this ionization energies with their values. See, ionization energy means what? Species with more stable electronic configuration. See, for element A we need to remove electron, that is was ionization energy. So now if this element is already stable, having more stable electronic configuration, is it easy to remove the electron? Already it is more stable. Now if we want to remove electron, it will becoming unstable. Therefore species with stable electronic configuration require more energy to remove electron. So which is more stable electronic configuration here? See, it is having half filled configuration, so it requires more energy. So which is having larger value here? 4. So C4, where do we have C4? So only one option now? Only this one now? So we can directly go with this. Okay, we will verify other options also. Now just follow, I will be giving you first group second period elements. What are the second period elements? Beryllium, carbon, nitrogen, oxygen. Yes, tell me, for this which is more electronegative here? Fluorine. Now it requires one electron to fulfill its electronic configuration, therefore it tends to gain electron but not to lose the electron. Therefore it is having highest ionization energy. Tendency to gain remove electron is very least, but to gain the electron is more for fluorine. So tendency to gain electron is more for fluorine, but to lose the electron it is least. That's why we are writing it is having high ionization energy. Clear or not? Why I am writing fluorine is highest? It is having Np5 electronic configuration now. Now by adding one electron it will become, but by removing one electron it becomes unstable. Therefore it won't give that one electron from here. It tries to gain the electron but not to lose the electron. Done? Next, for this we have P3, for this we have P4. By removing one electron here it becomes half filled P3 configuration, but by removing one electron it becomes P2, which is unstable, which is already in stable half filled configuration. Therefore this will be having more than the oxygen. Clear now? After this carbon will be having more than this boron. Okay, between boron and beryllium, beryllium just write 2s2 now. For this 2s2 2p 1. See, this one electron is easy to remove, then this fully filled 2s orbital electrons. So these are s orbital electrons are very close to the nucleus, therefore in order to remove that electron it requires more energy. That is what we call penetrating capacity of s orbital is more, it means more close to the nucleus. Therefore beryllium ionization energy is more than this boron. So here we should write boron, beryllium, boron, least is lithium. So now from this you can arrange. So fluorine is not see, fluorine electronic configuration is not given. Then next nitrogen is given now. This is nitrogen electronic configuration. So highest value is for that. Done. After this, look at this. This electron configuration corresponds to oxygen. So B corresponds to which value here? B3. B3. So B3. B3. So B3. Do we have B3? C4 B3. C4 B3 is not there now. C4 B3. Okay, so here B3 should be there now. Okay, let us match this. C4 B3. Then next, let us make our own answer. Then next, what we have? This is beryllium configuration now, which is having more value than D. Okay, so least value should be for this D. So least is, where do we have D1? So D1 I am writing. Then next, what we are remaining with? A2. A2. So A2 is there in which options? So let me check this once again. So A2. Okay, A2 here we have. The next B4. B4 they are giving now. So B4, no, C4 only here. D1, okay, between these two options we need to verify once again. So B means what? B, see, oxygen is having lower value than nitrogen now. So this is nitrogen electronic configuration, which means nitrogen should have more value than this oxygen. Definitely that should be like that only now. So it means C should be highest. So it means our option only, this is the perfect answer, but I think there is no exact like that. So we can go with this option only. Okay, maybe printing mistake like that you can consider, but this is a perfect answer. Okay, next. What about this? Om Prakash Sahu. Hello ma'am. Yeah, so tell me. So first ionization enthalpies of this one, nitrogen, oxygen, boron. From this you can say second option. Okay, next. That is about ionization, periodic properties and its classification we have did to some extent. Okay, so in this bridge course that is enough. So now we'll look into the chemical bonding topic. Okay, so let us have some basic idea on this also. Okay, so now, so chemical bonding, what exactly it means? It is an attractive force which holds the constituent atoms or ions in the chemical of a chemical species in a chemical bond. Okay, is known as chemical bond. For example, A and B are the two species elements, let us say, elements or ions, let us say. So now these two are held together by some reasons. Okay, so the reason, that whatever the reason we are saying, so due to some reason it is held by together, maybe some electrostatic force of attraction or some other things, by some other reasons. So that force of attraction which is holding them together is called chemical bond. So this chemical bond of different types, maybe by electrostatic force of attraction we are saying, so that results to form ionic bond. Okay, sometimes, so this electron is deficient by, this atom is deficient by one electron, this is also deficient by one electron, by mutual sharing. See, if you give to them and they are giving to you, they, by somehow they are getting fulfilled, right? So by mutual sharing of two species getting formed, okay, it means the sharing of electrons is taking place now. So due to that reason we will be having covalent bond. Okay, so there are some other types of bonds also, like metallic bond, which we are seeing in metals, okay, and hydrogen bond. Okay, so these are also there. So let us understand these types of bonds also. But what is the reason in order to form a chemical bond? Why chemical bond formation takes place? See, everything in the universe, as humans, we are also doing things in order to get stability in our life, right? In order to get settled in our life with most care, right? So that is what in chemistry also, in the species, in these chemical reactions also. So nature loves chemistry in order to gain that stability. Nature loves this stability. In order to gain that stability, chemical reactions are taking place. Okay, so these stability can be gained by few processes. So what are these? Okay, so elements try to attain noble gas configuration like this. So the species with this configuration are generally considered to be stable. Why? Because all the orbitals are fully filled. Okay, so therefore overall atom will become neutral and it will gain maximum stability. Okay, so this can be achieved by transfer of electrons. It means, for example, we have alkali metals like sodium having 11 electrons. By losing one electron, it will become Na plus, and one electron is lost by this. Now it is becoming 10 electrons, which is having 2s2 2p 6 electronic configuration like this, 2s2 2p6, which is stable electronic configuration, that is corresponds to neon gas configuration, right? So now this, whatever the electron lost here, that will be taken by, for example, chlorine. If I say it is having 17 electrons, by gaining that one electron, by taking this one electron, it becomes Cl minus 18 electron, which is having again argon gas configuration, having electronic configuration like Ns2 Np6 3s2 3p6, right? So by this reason, see, sodium is losing one electron, chlorine is gaining one electron, therefore we are resulting to get two ions like Na plus Cl minus. Now a cation, anion with oppositely charged species are there, they are attracted by, there will be some electrostatic attraction between them, right? So which results to form ionic compound, that is done by transfer of electron. Again what I told you, mutual sharing forms covalent bond. Next, donation of electron, lone pair electrons, that is what day 2 bond we can say. Okay, so I will show you that after some time. Okay, so attractive, so what are the types of bonds we discussed? Covalent bond. Next, that lone pair of electrons, for example here I have BF3. Now it is having 6 electrons only. In order to gain octet configuration, it requires 2 more electrons, right? It means 8 electrons like Ns2 Np6 electronic configuration if we require to get this boron. Okay, so this many electrons are required, 8 electrons are required, but boron having only 6 electrons are there. It means one empty orbital is there. To that, if we take ammonia, see nitrogen having lone pair now, so this will be donated to this. Only one atom is donating now, so now the bond will be looking like this, something like this. So this type of bonds are called coordinate covalent bond. Okay, next, metallic bond formed between the metals, and hydrogen bond. Okay, it's a special type of bond again. So next, van der Waals bonds. So those are just by the dipole-dipole interactions. So one element donates the electron, other element accepts the electron, therefore resulting to form an ionic compound, that is by complete transfer of electron taking place. Next, in covalent bond, mutually sharing, for example A required 1 electron and this both will share one electron and becomes a AA molecule. Like this we have hydrogen becoming H2, oxygen O2 molecule like this. Okay, so nitrogen by sharing of 3 electrons mutually we are getting N2. So double, triple, single bond formation takes place. Now look here, now each nitrogen having how many electrons? See, each bond contains 2 electrons now, 3 bonds, 3 2 is 6, 7, 8. This side also 8, both are happy now, because by gaining fully filled electronic configuration. So who is at L? Good afternoon. Next, so what are the differences between ionic and covalent? So ionic compounds are generally solid, like you can see rock salt, NaCl, that will be in the solid state, na? Crystals. And covalent compounds can be in the liquid, gas and solid state, all the three states. Okay, so now like water is a covalent compound, I can say polar covalent compound, so it is in liquid state, na? So CO2 gaseous state, covalent compound. Like that it can be glucose, if you say, how it will be? Powder form, na? So it can be solid, liquid, gaseous form. Okay, so now melting point, it is high for ionic compounds when we compare with these covalent compounds, and it will be having low, okay, due to electrostatic forces. Conductivity, ionic compounds are like these compounds are very good conductors in their molten state or in their aqueous state. But if we consider the solid state, they are insulator, or they are poor conductors, I can say. In which form they are poor conductors? Solid state. Okay, but in their molten state and in aqueous state they are good conductors due to presence of free ions. So whereas covalent compounds are poor conductors. Okay, then next, the formula of ionic compound, tell me answer for this. Ionic compound formed between sodium and sulfur. So tell me how the ionic compound is formed between these two. We know sodium loses one electron and forms electron, whereas sulfur having how many electrons? So in order to fulfill its octet, how many required? 2 more required, na? So therefore it means 2 electrons are required, means, so therefore it will become atomic number 16 with -2 charge, 18 electrons it required formed. Now in order to gain these 2 electrons, so I can take this 2. So what is the resulting compound now? Na2. Yes, that's it, like this. Lewis dot structure. So in order to explain the like how the molecules are existing, so he given his first explanation, that is what Lewis dot structure. So he told that outer electrons only take part in the bonding. It means for lithium, how many outer electrons are there? 1s2, 2s1. So this 1 electron only taking part in the bond formation, highest energy level. So for beryllium, 1s2, so these 2 electrons, it means he consider them as each electron is represented with 1 dot, that is what Lewis dot structure. Next, boron, 2s2, 1, so 3 electrons, 1, 2, 3, 3 dots. Next, carbon, 2s2, 2p, 2, 4, nitrogen, 5 unpaired electrons, so 5 dots, like that. Okay, so now an element shown with the an element is shown with its symbol, dots representing the valence electron, that is what we have written here. Next, so this is given by Kozel and Lewis. Okay, every atom tends to attain noble gas configuration, 8 valence, this is known as octet rule. So if only 2 electrons are present, we can say duplet configuration, that is for hydrogen and helium we can say. Okay, it is known as duplet. Okay, conclusion, only those compounds are that follow octet configuration is duplet, and like inert gas configuration is considered to be stable. Okay, so by considering this one statement, he explained the stability of compounds. So therefore it is applicable to few set of compounds, but not to the all the compounds. Like for example methane, how many electrons are there around the carbon? Valency 4 dots. Hydrogen, how many are there? 1 electron, now 1s1. So by sharing this, now it is getting 2 electrons, duplet. Now this side I go again 1, so here also again 1, here also 1 more. So total carbon is having, see how many electrons are there. One line represents 2 electrons, now 1 bond. So 8 electrons. Octet configuration is getting now. So it is having now 2s2 2p6 electronic configuration for carbon. For hydrogen 1s2, right? So it means it is stable. Now when I am considering BCl3, boron having 3 unpaired electrons, let us put like this. Let us put like this. So now this side 1 chlorine, this side 1 chlorine, because chlorine required how many electrons? 7 electrons are there around the chlorine. 1 electron is required like this. Each chlorine plays same role here. Now consider chlorine, how many electrons are there now? 8 chlorine are happy here. But what about boron here, central boron? 6 electrons only now. It means this molecule is existing, but what he told, only those compounds are stable which are having octet. Just consider about boron, how many are there? Is it it is satisfying octet rule? No, no, but it is existing. So he was unable to explain this. So this considered to be the limitation of his explanation. So what are the limitation? Incomplete octet. They are existing, but he was unable to explain how they are existing, even though they are not having octet configuration. Some are expanded octet. It means 8 electrons are octet. If it is less than 8, incomplete. More than 8, for example, PCl5 is having 10. It is existing, but he told that only 8 electrons are stable. So, but it is also existing, not explained. What is the reason behind this? By Lewis. Next, noble gases. What he told? Noble gases configuration compounds are more stable. It means noble gases more stable means they should not show reactivity now, but xenon is reacting and forming some compounds also. But why they are, even though they are stable, why they are reacting and why they are forming the compounds? He was not able to explain this reactivity of these noble gases. So this is also one more reason, limitation. And one more limitation is also there. He was unable to explain the structure of molecules, like BCl3 is forming, methane is forming. What is their structures then? Methane is forming, he is saying methane is existing and it is stabilizing now, by octet configuration. What is their structure? How the orientation of hydrogen atoms around the carbon takes place is not explained by Lewis. We are studying the tetrahedral structure, that was not explained by him. This is also one more limitation. Hope it is clear. Now let us solve this question. Give a try from your side. So from online students, those who are watching in live, so try to answer this in the comment box. Option? Both we discussed, na? Tell me. Five, 6, 7, what about them? Are they violating or they are following? Fast. SF6 having how many electrons? Sulfur. Fluorine is monovalent, na? So 6 bonds it is around. It means 12 electrons. So this is violating. So violating, this is also violating, xenon compound violating. Carbonate, it is following. So just see how do we write the structure? Carbon, oxygen, like this, one more bond, here one oxygen, negative charge and one oxygen, other satisfied. See carbon having 4 bonds now, 8 electrons are satisfied, this is also 8, this is also 8, this is also 8. Okay, so this is satisfying. This one are not satisfied. That's it. Hope it is clear now. Any confusions? No. Answer this last question. Fast. Which of the following contain both ionic and covalent? NaO is ionic or covalent? See, if you see Na plus OH minus, it will be like ionic. Now I am asking both ionic and covalent bond. I am asking. I am not asking which of the following is ionic compound. So between O and H, that is what? Covalent bond only, na? So it contains both ionic as well as covalent. This is correct only. And verify other options also. Fast. See, between K, we can write K plus Cn minus. But Cn also exists 3 bonds now. These are what now? Covalent. Na plus Cl minus. This is ionic. So this is also covalent and ionic both. This one also sulfate ion, SO4 minus 2, Na plus 1, ionic, as well as between sulfur and oxygen we have covalent bonds. So this is also, all 3 of them are having both. Now I am writing NaCl. Only we have Na plus. This is ionic. Now I am writing KCN over KBr and NaCN. KBr, tell me fast. Ionic. K plus Br minus. This one? Both covalent and ionic. So this is also both covalent and ionic. Same like KCN only. Hope it is clear now? Yeah. So this is about the class. Who is this? Saif? Saif, good afternoon. My name is Fatima. Fatima, good afternoon. Yeah. So this is about the session. So if you have any doubts, you can ask me. Otherwise, we will wind up the class. We will discuss in the next class. Any doubts are there? No doubts. Fine. Then online students, live students, do you have any doubts? If no doubts, I am winding up the class. Okay then.